Rockstar VIP. Okay, we're just gonna get the live feed going, and then we'll officially get started. Okay, we're good. All right, welcome to the December Seattle Openstack Meetup. Raise your hand or signal if this is your very first meetup. Oh wow, good. Congratulations, you've chosen well. This is always a fun group. We're usually bigger than this, but I'm thinking that it's holiday time and it's really cold outside, so people were discouraged from making it in tonight. So thank you so much for making it in tonight. We have dinner provided by HP. If you haven't had a sandwich from Jimmy John's, go ahead over there. There are vegetarian options for those of you who are vegetarian. If you need to use the restroom at any time this evening, our code is 0068. Summer of Love. Easy way to remember. We also have a special guest from HP. The sponsor is also our speaker tonight, and he is Nathaniel. He's right over here, and he's going to talk about the Openstack security project. So please give him a warm welcome.
Thank you. My name is Nathaniel. I'm a security engineer from Hewlett Packard Enterprise, and I am a member of the Openstack Security Group project, which is what I'm here to talk to you about tonight. So this deck was built collaboratively between HP, Red Hat, Rackspace, and a couple other guys. Hopefully, as this is a OpenStack meetup, you guys will be familiar with the first part, so I'm going to go through pretty quickly. It is an open source cloud platform written mostly in Python.
Great, guys. Looks like this kicked off the share. Oh, what's this full screen? Pardon me. Thank you.
Yeah, so open source cloud platform developed by NASA and Rackspace, and these numbers were pulled in June, so ignore today. About 2.5 million lines of code and about 1,800 contributors, between 75 and 80% of which is written in Python. So obligatory confused handoff when you're talking about infrastructure as a service, open source, if you're talking about cloud platforms, they typically contain some type of compute. How are you going to run the jobs that you're handling, those services? You have different types of storage, object, and others, which I'm blanking on because I don't like speaking in front of people. I apologize. You have network, and then you also have identity, who has access to what in those situations. And we like to sort of try to package that into these nice disparate domains. But anybody who's really tried to install it, anybody's tried to secure it, anybody's done a NetFlow, understands that it really kind of looks like this, and it really relies on a lot of other services to help run it and help keep it going. So I am here to talk about the OpenStack security project, which only recently came into existence. We had a vulnerability in OpenStack, very early OpenStack. If you're looking for the launchpad bug, one of the earliest we could find was 726359. And it sort of happened right between Bexar and Cactus. And so around the time of Cactus, the Cactus release, there was an email from Rackspace that said, we really need to have a public-facing group that can identify, isolate, fix, and respond, report, and describe these vulnerabilities and release them. We are public-facing security liaisons. That sort of lay dormant until about the Diablo release, when 3 or 4 guys got together and created what is currently the VMT. These guys got together and said, we really do need people to accept, isolate, identify, and triage vulnerabilities in OpenStack code. And so the VMT focused on that, and I believe are still doing a pretty good job of that. And up through about between Essex and Folsom, some other people got together, specifically Brian Payne from Nebula and Rob Clark from HP, and a couple other people said, we also need people who are willing to do tooling around security, who are willing to deal with other issues that are not specifically responding to issues in code. Some examples of these issues, which I think is actually a very good progression, are here. So through 2012 and 2013, with these first two, you see some relatively new software product bugs. We see arbitrary file creations, directory traversal, you're not sanitizing user input, and different things like that. And it was in 2014, I'm going to refer back, we're sort of getting into this time frame right here, after the OSSG was created, that you started seeing very specific security analysis. We started looking at the communication between services. We started looking at what was going on. We started seeing that, for example, people weren't checking for SSL. And then past that, we see very specific service-based attacks and service-based analysis. We see, looking at Glance and how Glance, the workflow through Glance. This is actually because there's a two-step process between the Glance image creation and image upload. You can do a DDoS on it. Or through Swift, you can have the specific Swift authorization checks. And so through 2012 and 2015, and we're actually on track to beat this number. We're at 25, 2015, which is nice. But you see a lot of these security issues coming in. We deal with pretty much everything across the board. Yeah?
What does the x-axis say on that chart?
So this is year, and this is number of advisories, and those advisories are OSSAs, or Openstack Security Advisories, which are equivalent to CVEs. And while I will touch on a lot of those, I am here to talk about the entirety of the OpenStack security project, which is mostly covered in here. There are two more that I'll mention, but not really touch on. So the security project, it does encompass the VMT that I mentioned, but they do remain to this day sort of an autonomous unit. They operate independently of the OSSP, even though they are encompassed by it. Some of the different things it covers are developer guidance for issues that we see are very common in code, but relatively easy to remediate if you know what you're doing. Some security notes are the pragmatic fixes for common security issues. The OpenStack security guide, when you are architecting your security deployment, we recommend you go here to sort of plan and get your best practices. Threat analysis is an initiative that we were able to do a few years ago, and we are really trying to start up again. And then our current tooling is Bandit and Anchor. Bandit is a security analysis tool for Python, and Anchor is an ephemeral PKI tool, which is pretty cool, having worked in PKI space myself. We also have, this should start getting more orange. We have a couple API testing tools that are entering the space, which are very good. And then another initiative that we're starting to go through is a cryptography audit testing tool, or testing initiative. So I touched on the VMT, the vulnerability management team. They ensure that vulnerabilities or reported issues, security issues with code, are dealt with quickly and efficiently throughout OpenStack. And when the situation calls for it, they issue an OSSA, or OpenStack Security Advisory. This is commonly done with a CVE. And we do have, there are 3 full-time guys, 4 every once in a while, but we do have a member of the VMT with us, Graham Murphy. So he can correct me when I say something completely egregious. So when we have an issue, they do all have GPG keys published or in Launchpad, when you report a bug, there is a checkbox to mark as a security vulnerability, and this marks it private and hides it from everybody else, all of the plebeians. It hides it from being easily exploited by somebody who might be malicious. So when they receive a bug like that and accept that it is a vulnerability, it sort of moves into a dual effort. They create a patch for it, so they analyze the code and see how that works and see how they can fix it. And they also develop a draft impact decision, which is how it affects the service and what effect the patch has on it, so that that can be taken into effect when you're applying the patch in your environment. Those are both uploaded into Garrett, where the VMT, or the Vulnerability Management Team, will review it and bring in service contributors, either cores or key contributors as necessary, depending on the service. That will, how many people have contributed to Openstack? So they will plus one, plus two, or minus one, minus two as necessary. And so that moves through the process of development and review. This is sort of a dotted line, less than a single line. Getting a CVE, does it depend on an external entity? So they don't necessarily wait for that, as we'll see in the example. But when an issue is severe enough, they will request a CVE. Once that, I walked through this, and one of the guys told me not to say so much, so I apologize. Once they are completed with that, it does go to a responsible disclosure and a key stakeholders list, where it will then pass through a time period and be published to the world. And once that occurs, the bug will be marked public with the patch and all fixes. They will be merged into master, and it will be open to everybody. The OSSA will be published. And so, for example, Cisco in 2013 found a cross-site scripting vulnerability in Horizon. And so it was reported in early November, and by the 14th of November, it was publicly disclosed, and everybody was able to see the vulnerability, see how it worked, and act on it. By the 28th, 2 weeks after it was publicly disclosed, the backports for the two minus versions were complete. And in early December, about a month after, a CVE was assigned, and approximately a month and a week later, everything, including the full OSSA, was published. So it's a very streamlined process. The complement to the vulnerability management team and their OSSAs is OSSNs. Who here has heard of OSSNs? I had a feeling. The Openstack security notes are the pragmatic uses for security in the environment. They're meant to complement OSSAs. So anything that doesn't have a patch or won't be fixed by a patch release, insecure defaults, or very common insecure configurations are bundled into an Openstack security note, or OSSN. As of December 2015, so as of today, there are over 60 listed. I highly recommend you taking a look at them. Some of them are deployment specific, some of them are configuration specific, some of them are version specific, and I would definitely recommend giving all 60 a quick glance through to make sure there's no impact. For example, number 56, cached keystone tokens can be accepted after revocation due to the default cache time. Or in 49, the no ironic driver can log sensitive information in debug mode. They don't use Oslo masking. So you're capturing passwords, you're capturing tokens, you're capturing things that if you don't handle this file in a sensitive fashion, it can be used, can be reused. The credentials can be reused by a malicious user. Swift client is vulnerable for this as well. Again, depending on your version and configuration. And if you're using pecan, some service, if you run pecan in debug mode, will automatically knock the service into debug mode as well. There are 3 or 4 services, including Ironic, that have patches for this. So again, highly version and configuration dependent. When we're creating an OSSN, there is a Launchpad group for this. So you can go into Launchpad, search OSSN, and find, I think there are 3 or 4 current topics that need OSSN write-ups. And you can get on Launchpad, assign a bug. There's a wiki that you get the number off of. I believe the number is 62, so the next one will be 63. You grab the template, title it. Again, with the template, it has a 1-line sort of executive summary. It has a 1-line summary, an executive summary, and then a detailed analysis, along with a remediation and recommended fix and links at the bottom. This is all done in about 150 to 200 lines, so they are meant to be kept pretty short and relatively easy to consume. And the links are there if you want to dig in if the issue affects you. And so the whole process for that is fun, and there will be a slide of links at the end as well. Outside of the pragmatic implementations of security is the Openstack Security Guide. In 2013, a bunch of people from Rackspace, HP, Red Hat, the NSA, IBM, and a few other places got into a room with a whole bunch of sticky notes. And at the end of it, they came out with the Openstack Security Guide. It is a living document, so it is meant to reflect the current state of security within Openstack. Very similar to OSSNs, they have their own section in Launchpad. Assign a bug. On the repo, the Security Guide repo contains OSSNs, the Security Guide, as well as the threat analysis, which again I'll touch on later. We just make the update into Security Guide source and the chapter name and file name. After that, it will get uploaded into Garrett, where security cores and as needed service owners will review it and will be published. The HTML version is updated as quickly as Jenkins can do it, which is variable. I like the chuckles. I'm going to reference that later. Anyway, the print version, the Lulu version, if you go to this link, there will be a Leaf version that is the 1.0. So you can, if you decide to order it, you can see how big of a change has occurred between now and then. These are some example topics that are covered in the Openstack Security Guide, which include hypervisor selection, how to pick your scheduler filters, things like that, instance security management, dealing with how instances are spun up in a secure way, and tenant data privacy, which is obviously maintaining the integrity of an individual tenant. So from there, we launch into the tooling that OpenStack, the OpenStack Security Project, has created. And probably the most successful is Bandit, which is a security, a Python source code analyzer. It's meant to find obvious security issues in Python code. These are some of the modules that it uses, and I'm actually a little bit disappointed that my boss was unable to join us today. Jamie Finnegan was the original author of Bandit. We were kicking around the idea of grepping the source code with clever regexes in an OpenStack mid-cycle. And he sort of sat there and said, and walked out of the room, which is never comforting in a security meeting. But he came back the next day, and he had the 0.1 version of Bandit, which was pretty cool. So this is an example of the Bandit tool running. And we try to make it as developer-friendly as possible, so the output comes color-coded along with lines of context. Typically, it gives you the line before, the line that is Bandit triggered on, and the line after. This one only has 2 lines because it's the beginning of the file, and this one you can see all 3 lines of context. This is default. These are configurable through flags, and obviously, I highly recommend making sure that this tool is tuned to your environment. And for example, the red, we have a high severity and high confidence. So if you're using, this example is specifically searching for XML RPC lib. And we're pretty sure that if you're using that, there's a better way to do what you want to do than using that library. So we have a very high confidence that we found a version of XML RPC lib. And we also have a very high confidence the severity of that use. In this, we have YAML load. And so this is sort of where we get into the state tracking. When we have a high confidence that we found a YAML.load, as you can see right here. But the severity of that is medium, because unless you're able to track variables from their inception to where they're used, you need to be able to have a little bit of leeway that those variables have been sanitized and other things are not going on. So this is the link for Bandit. We highly recommend you take a look. The tests are in bandit/modules. So please feel free to take a look at them, rip them apart, build new ones. If you saw anything on this list that you see is missing, it may be in bandit/modules.
Is this a Openstack module specific or Python generic?
It is Python generic at the moment. So Bandit was built to be Python encompassing. So it will work on a lot of Python code. We actually do have one contributor who is not an Openstack user or consumer that does use that for their code analysis. It runs quickly with low resource requirements. Again, we were sitting around, kicking around clever grep statements and regexes, and we really wanted somebody to be able to come in, take a look at it, understand what it was doing, and we wanted it to run quickly as well. And so the proprietary tools that we had at the time, again, as I mentioned, I would talk about as quickly as the gate would allow. And that was one of the things that we didn't want to add to time in the gate. Currently, Bandit is voting in 3 projects, I believe: Keystone, Keystone Client, and Keystone API, or API Client. It is non-voting in 5 others, including Magnum, Barbican, and Oslo, VMware, I think. So we wanted something that would be able to sit in the gate and not be blocking. We wanted security to be an enhancement to what already existed within Openstack, or Python in general. About, I guess it was 2 mid-cycles ago, we found that we were dealing with a lot of the same things over and over again. We found a lot of issues in code that we were having to train developers on. So we also came up with secure coding guidelines. And these are colloquial descriptions of commonly made programming insecurities. And the goal, so they have an introduction into the issue, an example of insecure usage of Python, an analysis of why that's insecure, an example of secure Python, and an analysis of why that is secure. And the goal is for that to eventually plug into Bandit. And so for all the modules we have in Bandit, we would like to say, we found something, XML RPC lib, for example. Why don't you take a look at this? And it ties back into a secure development guideline. You can then go have all the tools at your fingertips to do things in a secure fashion. Anchor is one of the more fun things that I get to talk about. It is an ephemeral PKI system, and it was built on the experience of running PKI at scale in HP's public cloud. And so for all of our tenants and all of our domains, we have a manual approval and a manual validation process of each individual PKI certificate that was requested. We looked into automating this, and what we found was that revocation is broken outside the browser. There are many crypto libraries, especially in Python, that don't implement all of the different functions. Including OSCP, and there were many challenges through both trying to validate certificates, trying to have some type of OSCP cache. I mean, if you're talking about revocation lists and maintaining them and pushing them out when a certificate is revoked, when something happens, it's non-trivial. It's good, and Bandit was our answer to that. So what we have is the feature we saw that was actually checked by most developers, which was expert. And so Anchor will automatically verify and issue short life certificates so that you can have a certificate that is given a short amount of life that when something happens, you can then act on that. A request will come in over TLS, and that way we can have an assurance of the host name and the IP address. It'll go through a set of validators, and if it passes those validators, the certificate will issue. And then it goes into passive revocation. The certificate is valid for a default time period. Again, all of these tools are open source, and so these are configurable. The default for Anchor is 24 hours. So if you have automated, for example, automated quarantine, any host that is identified as being compromised will then be moved off into a separate subnet. And by definition, if you're using validators, they can deny based on where that IP address comes in. The other benefit is that the Anchor certificates will have a shorter life than typical OSCP caches. So your ephemeral certificate authority will look somewhat like this. You'll have a RESTful certificate authority, a RESTful interface that will accept that incoming request, once again over TLS. It'll go to your pluggable authentication, so you can validate, is this service in Keystone? Is it in LDAP? Is it in AD? Is it in, does it have some type of shared secret? It can move down to the decision engine, those validators. It can say, I have the IP address. I have the host name. Do I expect my Seattle prod compute nodes to have this IP address or be from this range? It can do a reverse DNS verification. It can make a call to your CMDB. Is this a host that I know about, that I know exists in my environment, that I have registered and inserted? It has a lights out interface. It's reported in what versions. It has all the information we require when we set an asset in the CMDB. And it's an extendable rule set, so you can create validators per your environment if you want even additional assurance. And then finally, it will, once it passes your validators, it'll go to your certificate authority. And this can be Microsoft ADCS. It can be DogTag and FreeIPA. I mentioned there were two projects I wasn't really going to highlight, and Killick is one of them. We were a little frustrated at the prospect of standing up FreeIPA, configuring it, and then configuring DogTag to work with FreeIPA and working with Anchor every time we wanted to test it. So we also, a work in progress is Killick, which is a lightweight certificate authority. Yeah.
I'm a little bit confused about this drawing here. If I understand it, the authorization function is in the CA as opposed to the service that is being authorized. I understand that the CA is issuing something that authenticates where the request is coming from, but isn't the decision in the component that is providing the service as, I'm not doing a good job explaining it.
Yes, so the service and that's actually how you want to configure it. You want the service to request a certificate. And you want to do it before the certificate expires with enough time for you to act on it if it's denied. So yes, the service will make a request. It will generate a CSR, hopefully with all of the information that you give it. Once again, we're talking at scale. We're talking in a cloud environment with however many. So you have an automated system to generate a certificate for a service on a host, and then request the certificate from your anchor, or if you're using Castellan, from your brokerage service. So it will generate a CSR and make the request over TLS. And then Anchor will say, we validate that you are coming from this IP address, from this host name, and it will go through those validators. Does that make sense?
Yes, thank you.
And so the last tool I'd like to talk about is CentralBoss. And CentralBoss is an API testing tool that came out of Rackspace. It is built to fuzz the payload, the headers, the URL, and the query string, which means it can do fun things like SQL injection. The unique things about it is it logs all of the raw requests and response and has keystone authentication. So it is really interesting in how it works. So if you put together a call, you can actually plug in a keystone. This is doing it twice. And it plugs in to get a keystone token and a UUID. This is an example of a CentralBoss payload. It's built on OpenCafe, so it is an API interaction tool with a keystone interaction built on top of that, the keystone implementation. So this example will actually cause a significant amount of output. And what CentralBoss does is it takes the test name and it creates a directory structure of logging underneath that. So the full out, this is the summary output. It logs and produces the request and response output, or request and response traffic, and then produces a summary output at the end. So you can see the test case that will be your directory structure on where those messages are logged, the raw messages, if you want to go back and validate them. It also contains what test you make, as well as whether it passed, how many were run, and how many passed and how many failed.
Okay.
Yeah.
Is CentralBoss generalizable to the point where I can use it to any RESTful API, or is it specific to Openstack?
So CentralBoss is actually built to support keystone authentication. So it's built on OpenCafe, so it probably could be extended. It is open source, but it is out of the box configured to geared towards keystone. And actually, thank you for the question. About a month ago, Red Hat released REST Fuzz. So CentralBoss is under the Openstack GitHub umbrella. REST Fuzz is not. It was built by one of the guys in the VFT, so I fully expect it to work with Openstack. However, he has not brought it into the Openstack GitHub as of yet. I hate this slide. Anyway, so the Openstack group, I'm gonna fly back here. The Openstack group was brought in between the Essex and Grizzly timeframe, but as of Juno, we are actually the Openstack project. Right before Juno, right before Big Ten, we were accepted as a full project within Openstack. And we're looking for contributors, anybody who is interested in security, either in passing or in a more specific role. You can write notes or documentation, working on an OSSN, working on the security guide. We'll get you your technical contributor credit. So you do get however much off your next summit. You can hack on existing tools. We have, like I said, Bandit, Anchor, and CentralBoss are all within the OpenStack umbrella. They will all get you that technical contributor credit as well. Or you can write your own tool. In the last month, we've had a couple guys come to us say, we have this Ansible security project we want you guys to take a look at. We have these checks that we built for Barbican that I was asked to do in Designate as well, so I just threw together a whole bunch of Tempest checks, and those exist as well. If you're a pen tester, especially if you're beyond the DevStack scale, we'd love to understand how you view and approach any type of OpenStack deployment. Threat analysis, these last two are efforts that the OpenStack security group are really trying to put some force behind. We're trying to get moving. So threat analysis, if you're interested in a specific service, we would love to help you break it down and figure out what's talking to what internally, what ports are open, what type of calls are made between what modules, and how all of that works, get some data flow diagrams going. We have existing threat analysis work for Keystone. That has not been refreshed in about a year. There is an effort, the security core, who's also a Sahara core, Mike McCune, sent an email to the dev list last month. He's looking to do a threat analysis on Sahara, which is new on Openstack and other types of big data tracking. So there's a lot of interest in threat analysis. We also have verbal commitments from both Rackspace and HP to do threat analysis work, either support the project by contributing resources who have helped with threat analysis, or even our threat analysis work that we've done internally. Probably the former more than the latter. They would depend on anonymizing the environment, fun stuff like that. The last one is crypto tracking. If you understand cryptography algorithms, we would love to have you profile a service and look into how cryptography is used throughout the OpenStack project itself. How is it used? How is it abused? How is it misused? Authentication, hashing, fun stuff like that. So we are on OpenStack security in Freenode. We're lurking there most of the time. I'm assuming everybody here is Pacific. Is anybody not local? Fantastic. 9 o'clock on Thursdays, 9 in the morning. We are in OpenStack meeting alt every week. Do we have one this week?
I think we still have it.
We have one this week, and then we'll take a break for the holidays. So you can join this Thursday, and then we'll take a break. And on the mailing list, we are available on the dev list with the security tag. So I want to say thank you to Sula and Jason for setting up all of this stuff, and I will leave you with most of the links that I talked about. So, thank you.
So the security project you mentioned is working on this